Today I'm going to be talking about simplifying radicals, and this is something that's very scary for most students, that they just see a radical and they will not attempt the problem at all. But I'm here to tell you that radicals are not that difficult. They're just really scary looking. Okay, and radicals, the main thing we need to know about radicals is the backstory. Perfect squares. Okay, radicals derive from perfect squares. What are perfect squares? Perfect squares are when we take our common counting numbers, 1, 2, 3, 4, and we multiply them by themselves. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. All of these numbers that we get from resulting from multiplying the same number times itself is a perfect square. Okay, and so where do radicals come from that? Well, radicals are actually the backwards way of doing perfect squares. So in other words, if we take the square root of a perfect square, the answer is the number that we multiplied by itself. So in other words, the square root of 64 is 8, because if we multiplied 8 times 8, we would get 64. So the square root actually just undoes the double multiplication of 8 times 8. Okay, we say for every pair, we can take it out from underneath the radical. So in other words, if 64 is being multiplied, was replaced with that 8 times 8 underneath that radical, that means there's 8 times 8, 2 8s being multiplied there, and that means we can take 1 8 out from underneath the radical if it's a perfect square. Okay, so let's do an example real quick. And I do have some letters in here because most students do get confused whenever they see it with letters also. So the first problem I have is the square root of 125n. And I'm doing it two different ways here. Some people think about it as if we do a factor tree and we know that 125 is 25 times 5. Or in other words, just 5 times 5 times 5, that will give us 125. And we know since we have 5, 5, 5, we have 3 5s for every pair, every 2, we can take 1 out in front of the radical. And whatever's left underneath the radical just stays underneath the radical. You don't have to worry about it anymore. So once we take that 5 out in front, we're going to end up with radical 5n left, because these cancel out, these go away, and only 5n is left. Okay, another way people think about it, and this is more of the secondary math classes, the older math classes, older students are going to think about it this way. This is the way that I prefer. This is the way that I try to teach my 7th graders at the beginning, but I always say if you can't do it this way, just go back to this way. All right, if you're trying it this way, all I do is I think of the biggest perfect square that can go into the number that I'm talking about. So the biggest perfect square that goes into 125 is 25. 25 times 5. And I know that 25 from my list right here is a perfect square. So I know that I can take the square root of 25, which is 5, and whatever's left is just whatever's left. Okay, let's try another one. So for this example, I have the square root of 45p to the third. Okay, so the first thing I'm going to try to think about is what is the biggest perfect square that goes into 45? And that's a really easy one. It's 9. Again, you can use, if you need to write down your perfect squares to figure it out, that's perfectly fine. Okay, so 9 times 5 will give us 45, and I know that 9 is my perfect square. Also, we have that p to the third, so that's p times p times p, all three of them being multiplied together. Okay, so I'm going to take the square root of any perfect squares that I can, or any pairs. So here I have the perfect square of 9, so I'm going to take that 3, the square root of 9, 3 times 3. So we're going to take that 3 out in front. Okay, I know I have 1, 2, 3 p's. Well, how many pairs do I have? I have 1 pair. So that means I can take 1 p out in front. Okay, so I'm going to take that 3, the square root of 9, 3 times 3. So we're going to take that 3 out in front. Okay, I know I have 1, 2, 3 p's. Well, how many pairs do I have? I have 1 pair. So that means I can take 1 p out in front. Okay, and then all I have left over is 5 and p. And so my answer is 3p square root of 5p. Okay, let's do one more. This one has 2 letters in it. It's a little bit more difficult, but again, it's the same concept. So here we have 147, kind of a crazy number to try to think about. But if you use your list and you go through, you can find that 49 times 3 will give you 147. Okay, and so I'm going to put my perfect square times my other number, and then I'm going to list out my variables. This takes a long time. If you don't want to do that and you just know, oh, I have 3 m's, that means I can take a pair out, 1 pair out, 1 m, then that's the easiest way to think about it instead of listing them all out. Okay, so the square root of 49 we know is 7. We know we have 1, 2, 3 m's, so that means I can take 1 m out in front. Okay, and then I add n squared. So that means I have 2 n's. So that means I can take 1 n out. And there's no n's left. After you take 1 out from the pair out in front, you don't list it anymore. The 3 and the other m is all that's left over in our answer. So our final answer is 7 m n square root of 3m.